Hi, good morning, everyone. So we present our project POSMO, Mobility Tracking with ML. That's I'm Roger Fischer. That's Valery Fischer. So what is POSMO? POSMO stands for Positive Mobility. It's a platform for mobility data. And it's fed basically by what you said before with apps. We have two apps, POSMO Segments and POSMO One. And last but not least, it will also be Data Producer Cooperative, which we will found next month. So the apps, there is POSMO Segments. That's our first app that's already available. You can download it and record signal tracks. So to get an understanding how quick a bus drives, you have speed data and all the data is there. You can basically measure signal tracks. And POSMO One is the app that will come out next month, and that will track through a whole day. So you will have all the transport modes. So we classify basically transport modes on the fly and tell you how you move around. So it's an app. You put it once, you download it, and basically you don't have to do anything more. So what's the motivation behind what we are doing? I think the most important is really the kind of transparency to the user. And you can see that already. So if you download the POSMO Segments app, for example, you can see what you're really doing, how the data looks on a map. You can download the data. You can obviously also delete the data. And this is even more so for POSMO One, which, as I said, will come out in next month. You will be able to download your whole day and you see your whole day. And I think that's a really key thing. And Edward Snowden yesterday said that basically we only see partially what we do, and we try to really give you what we have. And the cooperative is also there basically so that we can always inform the cooperative and we can basically say what we're doing. Here's another example of how that will look. The other important thing for us is it's a holistic approach. So right now, Martha, you showed cars, and that's like the dominant model. And I mean, all the cars will have or have already data and will send them. And yeah, in the US particularly. And we think we really have to start with the person. It's a person thing, so that modes that we don't have much data about, like walking, running, and cycling especially, that we have really data about these modes, because we don't have data today, or a very smallish data, they are completely underrepresented. And so, yeah, I think the cooperative for us is really the thing to change the model. Snowden yesterday talked about leverage. I think if the ones who produce the data are in a cooperative, a data producer cooperative, then we have leverage and can maybe also change how the industry works today. And with that, I give over to Valery.
So hi, this wouldn't be an AMLD talk if we didn't talk about the ML behind everything. So the whole idea is we start with what is available. And when we kind of go from, when we start this problem, we kind of try to figure out how can we use data, how can we find the data that we need for us to succeed in really figuring out how a person is moving. And so this is kind of the view of POSMO Segments, which is our raw data gathering platform. And as we can see here, we kind of created this tool for us to really clean data and make it available for testing it out, experimenting with different machine learning approaches. And in essence, this is how our data looks like. It's just raw signal from all the sensors in our phone, and we kind of want to get a really understandable information out of that. So what is it that we want? Here's a really simple example. We go from the raw data that you can see on the left, which is just phone signal. We don't really know what's going on. And we want to go to the right side, which is a place which shows exactly how we are moving around, how our mobility is looking like just by analyzing the phone data that we gathered. Now, how are we going to do this? The basic principle is we have Android and iOS, which are the data gathering platforms. We pre-process our data in such a way that it can be easily implemented in a model, and then evaluate that and then put it back, stream it to the Android and iOS. But is it really that simple? I don't think so. I mean, first of all, the pre-processing is already a really big challenge, and also the evaluation. How do you make sure that the model really gives you what you want? And that brings me to my next question. How can we make the model do exactly what we want? Here are the current evaluation metrics for our model. As you can see, the really simple precision recall and F1 scores for our model don't look that bad. They look like we can really work with this data and figure out what is happening. Also here, another well-known evaluation metric, the confusion matrix, shows that maybe there's some problems with similar transport modes like car, tram, and bus, but other really distinct transport modes are easily detected. But this is looking really well. Then why isn't our thing working? Why aren't we already there? Why haven't we solved this problem totally? And that is because our data doesn't really, or the model doesn't really tell us everything. It just tells us what it thinks we're moving like, but we still have to piece everything together. And that is when we kind of try to create another labeling tool for us to kind of get the macro parts of movement out. And this is what you see here, our first version of this labeling tool. It's just a Jupyter notebook where we can see all the raw data and pretty much our GPS locations. And we try to kind of piece together where we went, what we did exactly at what times, and it got really hard. So after that, we kind of figured we need something else, something really easily understandable, where we can get all this information out. And this is what we ended up with. And here you can see really the model predictions mapped onto the GPS locations shown on the left screen, where we can, as users, kind of identify what is going on really easily. And then on the right side, we also have some of the most important for a user, from a user perspective, to kind of figure out what is happening. And this really helped us kind of figure out not only the transport mode parts, but also the kind of macro parts of movement. So when is a person actually moving and when is a person static, instead of just saying, oh, this person is using this transport mode, oh, this person is moving in this transport mode, but we really didn't know what was really going on. And with this, I think we can kind of figure out new ways to use machine learning together with older models that have been proven to have some problems, to really figure out what we can improve in. Nice.
Okay, with that, I'm going to kind of offer some questions for you guys for the whole day, basically. Or I think obviously it starts with defining things. So That's the first thing what we did, and I think it's still today in the industry, it's not very clear how we name things. Everybody names it a little bit differently, and so we start this process over and over, and then we are very imprecise. And so we just basically took that together, wrote a Medium article about it, and right now for us, the unit that's most important normally is the segment, which is a one transport mode thing or track. And so that's the first thing I think we should quickly come to a standardization so that we name things the same way. Then the second thing is here we compared ourselves to a competitor and we have a ground truth. Up there you see the ground truth at 8 in the evening it starts and then it goes upwards. And basically POSMO starts with 1 and goes up, and this app here goes up this way. And so what you see already, and that's what I mean with standardization, what is correct, what is incorrect, is that the ground truth has 11 segments. We also, in this case here, have 11 segments, but the competitor has only 9. So he left out 2 segments. And idle is for us, for example, important in the ground truth as well. And places. I mean, places, everybody is pretty much the same. That's the big parts, but idle is something that can be small or big. So basically, what the questions I will leave you with is, what do we consider as idle or a place? I think that's a super important question. Where are the boundaries there? And then naturally, do we have all segments and places, or do we basically say this is not important and keep it out? And the third question is then, do all segments and places start and stop at the right time? So, for example, the competitor keeps the waiting time at the tram station within the segment, and we think that's a problem. Because, I mean, it would help to know if you wait 15 minutes and then you move 15 minutes, or if you say this is 30 minutes segment. And so the last question is then really, how many segments are correctly classified? And with that, I give back, and I hope, you check POSMO 1 out in February. If you have questions, you can send me an email.